In this session, we will indeed carefully control the OLED display that we previously controlled with the nRF52840 module using the Raspberry Pi Pico. First, please carefully insert this important module. Now, there is one issue here. If you look at the pin map, you will see pin 14, GP10, and pin 15, GP11. Please note that GP10 is the I2C SDA data pin, and GP11 is the I2C clock pin. But the problem is, if you look here, again, GP10 has a portal for connecting the OLED, right? 3.3V. GND, SCL, SDA. However, the GP10 SDA data pin that I showed you earlier will be connected to SCL. And now, the GP11 SCL clock pin we saw earlier is connected to the data pin, the SDA pin, so the I2C pins are swapped. They are swapped, so if you just plug it in as it is, it won't work. It may be a bit cumbersome, but after carefully and thoroughly preparing the male and female jumper cables, please ensure that you connect them properly and securely. Now here is the specific order to follow. First, connect the ground, and then proceed with the 3.3V connection. It's the ground, SCL, and SDA, but for now, let's use 3.3V. You should connect the ground in the same order, but just swap the order of SCL and SDA. Now, I have connected it to the Raspberry Pi Pico, which is a small, versatile microcontroller board that is popular for various electronics projects due to its affordability and ease of use. Previously, when using the nRF52840 module, which is another type of microcontroller known for its Bluetooth capabilities, all the basic files were already installed, so there wasn't much to do. However, this time, there are quite a few additional files that need to be added to ensure everything functions correctly. First, if you go to this link, you will find the code page for Adafruit SSD 1306, which is a library used for controlling OLED displays. Here, just copy the file name from the end and create a new file in the lib folder with the same name. Then, copy the entire source code from here and paste it into that file. Save it. And next, if you go to this link, you will find the source code file for Adafruit Frame Bump, which is another library that helps in managing frame buffers for displays. Copy the file name and create a file with the same name in the library, and similarly, copy the entire source code from here and paste it into that file. Finally, you need to add the font file, and if you go to this link, you will see the download option. This font file is crucial for rendering text on the display, and without it, the display might not show any text or might show it incorrectly. Make sure to download the correct version of the font file to avoid compatibility issues. By clicking, you can download the font file oxfile.bin that we have seen many times before. Please download it. If you have downloaded the oxfile.bin file, please copy it and paste it into the CircuitPython drive of the Raspberry Pi Pico. Now we are ready. The source code for controlling the I2C OLED display is this one, which we used when we worked with the nRF52840 module before. In the event that you navigate to this particular link, it is important to first copy the link and then paste it into the designated area here. After doing so, you should modify the text to read from link volt SD. Additionally, it is crucial to shorten the link appropriately. Please be aware that this specific pin is distinct from others you may have encountered. Ensure that all steps are followed carefully to avoid any discrepancies or errors in the process. Please kindly save this document as GP11, GP10. Let me check it once. As you can see now, The OLED display shows lines, a rectangle, a circle, and the text, Hello Device Mart, right. As such, you can control it this way. In this session, I use CircuitPython to control the OLED I2C OLED display with the Raspberry Pi Pico. If you happen to control other I2C related sensors or components in the future, you can connect them to the OLED display by simply swapping the positions of SCL and SD just like we did this time. Then I will see you next time with different content.